Hello, geometry. So we are back for section 8.1. Sorry about that. So let's talk about section 8.1. Section 8.1 is geometric mean. I'm going to show you two things. One's like the easy way, one's like the visual way. So geometric mean means we're going to find the geometric mean between two numbers. We're going to solve problems with relationships between parts of right triangles. So I want you to just focus for a minute on this diagram right here. Right, so this diagram, in this diagram, it's triangle ABC. Do you see large triangle ABC? Do you see the small triangle to the left, ADB? And do you see then the medium-sized triangle BDC? We actually have three triangles there. So if an altitude is drawn, so remember an altitude goes from the vertex down and forms a right angle. So from vertex B down and forms a right angle at D. So if we draw an altitude from the vertex of a right triangle to its hypotenuse, then the two triangles formed are similar to the large given triangle and to each other. So I drew three triangles here, the large, the medium, and the small. And I have them, I've rotated or reflected them so that they're all kind of looking in the same shape. So same shape, different sizes, right? That's similar. We know this from chapter 7. So my large triangle, the right angle is at B. The long leg goes up to C, and BA is the short leg. If I had values, I could put those on there. On the medium triangle, that's this one right here. D is the right angle. DB is the shorter leg. I can tell just by looking at it. And DC is the longer leg. So then I'm going to do the same thing with the small triangle. So this little guy over here, this one's rotated or reflected. So D is the right angle again. We know, right, if D is marked here, it's got to be right there. DA is the short leg, and DB is the long leg. So if it's similar, if all three of those, once we pick them all apart and draw all three separate, we know that we can set up proportions to solve. So if I have information about the large and the small, I ignore the medium. If I have information about the medium and the small, I ignore the large. I just use whatever I've got, because remember we only need two triangles, two triangles to set up proportions. So to solve for missing lengths, separate, draw, and label, just like we just did. Then, typically, you can start with the two smaller, draw the large one if you need to, but start with the small and medium. Then you're going to put a variable for your unknown, right? We always do that in math. If we don't know, that's where we usually put an X. And we are going to use proportions from our similar triangles to find X. So it looks a lot like chapter 7 stuff. Similar triangles. Only they're just being sneaky with how they draw it the first time. They use one large right triangle and then drop that altitude from the vertex to a right angle on the opposite side. So let's do a quick setup here. Let's do problem number 2. Find C and D in triangle JKL. So let's draw these guys. I like to draw them all looking kind of the same way. So large, medium, small. Large, medium, small. All right, I don't like my small one. Let me redraw that one. All right, so in the large triangle, K is my right angle. Looks like the longer leg is KL. There's no information given. KJ is my shorter leg, and I know there's a D on that. Let's go to the small triangle. So this little guy over here. So M is my right angle. The short leg is MJ, and it says that that's 5. The long leg is MK, and that's 10. Let's label the medium. You can do this in any order, of course. So in the medium, M is my right angle. Have you noticed I always start with my right angle? It's the easiest angle to start with, right? Because we can identify it, and then we can look for long or short legs. So let's see, short leg it looks like is MK, and that length is 10. It's okay that we already used MK was 10. Looks like my long leg is ML, and that's a C. All right, is that everything? I think that's everything, right? So let's do a little bit of setting up a proportion. Actually, you know what? I forgot this, didn't I? On this largest triangle, the length of LJ, we know that the two pieces, in order to get the whole length, we got to add those two guys together, don't we? So that's C plus 5. All right, what do you want to start with, C or D? When I look at the C's, the C plus 5 is tough, but this C right here should correspond, doesn't it, with the 10 on the smaller? And then I've also got this pair of 10 and 5. So that seems helpful. So I could set myself up a C over 10. So my corresponding size equals 10 over 5. Cross multiply that. 5C equals 100. Divide, so C equals 20. The hardest part was writing out the whole thing, wasn't it? All right, so let's see what we've got next. You know what else I forgot to label? On the smallest triangle, KJ is also D. Sorry about that. I just realized I had some missing things. So notice on the large and the small, I have some corresponding parts. The hypotenuses, right, this and this, and then the smaller leg, the D and the 5. I am not scared that it's C plus 5 on here because we just found C, correct? C equals 20, so that side is actually 25. So this time I'm going to use my large and my small to set up a proportion. In the first problem to find C, I use this medium and the small. So if I set this up, I'm going to do hypotenuses. So I'm going to do 25 over D for the large to the small. And then I'm going to do that short leg equals D over 5. And cross multiply these guys. So D times D is D squared. 25 times 5 is 125. So here's where we needed that section 09. Everybody knows we're going to square root, correct? Right? The square root of 125. Here's the thing. I know that it's going to be 11 point something because I can use a calculator. But if I want an exact answer, I'm going to break down that 125 and figure out what perfect square goes into it. I'm pretty sure that 25 and 5, which one's a perfect square? 25 is a perfect square. Its square root is 5. The other square root of 5 doesn't go anywhere, so it stays as 5 square roots of 5. If we were doing rounded answers, D would be approximately, we can't even use an equal sign because it's not exact. I believe it comes out to 11.18. That's rounded, and that is a sad face, an angry face. We don't like rounded. We want precise, exact answers. But if you did get 11.18, you know you did it right. You just need to go back to your 09 notes. So that's one way to set this up. This works really great for visual people because you can see, as long as you don't forget to put things on there like I did, you can see everything. However, we could talk about the geometric mean. So the geometric mean is the same diagram. It's the altitude. It's that segment from the vertex to the right angle on the opposite side. The geometric mean is the altitude. It's always the positive square root of the product of two numbers. You know how I said if I was being technical, I could say it's positive and negative. Well, in this case, geometric mean is only positive. And it's actually a shortcut for setting up proportions without having to draw three triangles. Some of you are visual people, you like to see those. Some of you are shortcutters and you want to do the least amount of work possible. Well, here's your answer for that. So here's what the formula looks like. If A and B represent two numbers and X is the geometric mean that we're looking for, then A over X equals X over B. A over X equals X over B. It is not a coincidence that when you cross multiply, you're going to get X squared, just like we did on that last problem, and you're going to have to square things. So if I just gave you two numbers and said, hey, find the geometric mean, you'd be like, okay, I can do this. You just set yourself up a proportion. Let A and B be numbers. So 2 over X, X over 50, cross multiply and solve. So notice the X's stay as variables. The A and B, we just stick the numbers in there on the two diagonals. So X squared equals 100. Easy peasy when we square root that one. Thank goodness 100 is a perfect square, so X equals 10. Let's jump over to number 3, just because everybody's going to try to avoid these numbers, right? Because they have radicals in them. So A over X equals X over B. So square root of 3 over 2, X in the denominator, X in the second numerator, square root of 3 over 5. It's not as bad as it looks, I promise. When we cross multiply, we get X squared. When we go this way, we're doing a square root of 3 over 2 times a square root of 3 over 5. Multiply your numerators, multiply your denominators. You do not need common denominators for this. So that looks like a square root of 9 over 20. We all know the square root of 9 is 3. So 3 over 20. Then when we square root this, sorry, I was just looking at my misprint there. That's a square root of 3 over 5. So shouldn't that be a square root of 3 over 10? Some of you were wondering what I was talking about and how I was making up numbers. Square root of 3 over 2 times square root of 3 over 5. Okay. So now we're going to square root just like we have been. This is where we needed that section 0,9 again. We've got a square root of 3 over a square root of 10. Square root of 3. Remember, you can break it up. My number one rule, no radicals in the denominator. So what am I going to multiply by? Just reuse that denominator. Show me your work. So square root of 3 times square root of 10, that's easy, square root of 30. Square root of 10 times square root of 10, that's easy, square root of 100. Of course, we're going to simplify that. Does 30 break down at all? Is there any perfect square that goes into 30? I don't think there is there? 2 and 15, 3 and 10. I think we're just stuck with the square root of 30 over 10. Final answer. It's not pretty. If you were going to a decimal, if you were rounding, it would be approximately, I believe that's a 0.55. But I like the exact answer. All right. So that's how we set them up and do them. This is what we can do to use this as a shortcut for those triangles. So the measure of the altitude, remember the altitude is the geometric mean. So this would be my x from that formula that we just did. So the measure of an altitude is the geometric mean between the measures of the two segments of the hypotenuse. So in other words, if I took this segment of the hypotenuse and this segment of the hypotenuse, those would be A and B. So that formula, a over x equals x over b, can be applied. So it's the part of the hypotenuse over the altitude equals the altitude over the part of the hypotenuse. And I think I have that in here. Let me move this over. Part of the hypotenuse over the altitude equals the altitude over the other part of the hypotenuse. So that's nice, because now I don't have to draw 3 different triangles. So I just have to look at what information I am given. All right, so let's look at another one. So Theorem 8.3 says this. If we've got that altitude in there, then the measure of a leg of the triangle, so either leg xy or yz, the measure of the leg of the triangle is the geometric mean between the measures of the hypotenuse and the segment of the hypotenuse adjacent to that leg. You got that, right? So here's what it looks like. Hypotenuse over leg equals leg over closest piece of the hypotenuse. So basically, this would be A, this would be X, and this part, whoops, this part right here would be B. Or I could flip it around as well. If I did that the other way, let me take the same triangle. I could do hypotenuse A over X equals X over the closest part of the hypotenuse, so this little guy. I think of it almost like tracing. A over X equals X over B. And I only go the part way on the return trip. So we'll figure out which way makes the most sense to you. Let's do a couple problems, one of each of these guys. So remember, if we're looking for hypotenuses, let me go back. If we have the pieces of the hypotenuse from the first theorem that we just talked about, we do it that way. Look at what you're given. On this second one that we just did, I'm given or looking for a leg, and then I have pieces of hypotenuses. So the difference between these is that I have my X is on one of the legs instead of just hypotenuse information. So find C and D in triangle JKL. This might look familiar to you, but that's okay. We're going to do this a little different way. So let's start off with C. Let's start off by finding C, because here's how I trace this through. Part of the hypotenuse over leg equals leg over the other hypotenuse. That seems easy, right? So the part of the hypotenuse is 5 over the altitude 10. Repeat the 10, come back down over C. So if we cross multiply that, this is not hard. We don't even have a square in this one. 5C equals 100. Well, you might be shocked to learn we got that answer of 20 when we did this problem at the beginning. So part of the hypotenuse over the leg, or over the altitude, equals altitude over the other part of the hypotenuse. I don't know if that seems easier to you or harder to see. So then the other one, right, I said when we're given a piece of a leg, we do the whole hypotenuse over the leg equals the leg over the closer part of the hypotenuse. So we do know this whole hypotenuse, since C is 20, this whole thing is 25, right? So 25 over the leg that we're looking for, D, equals, come back down that leg, D over the closer part of the hypotenuse. This one, we end up getting a D squared equals 125. When we break that down, we end up D is exactly 5 roots of 5 If we were to go to a rounded value, we'd end up with something like 11.18. Right? So that one had both of them in there. So does this guy right here. So notice our x and our y for the last example are both on legs of the right triangle. So let's just start with x. So if I'm talking about legs, I do hypotenuse over leg equals leg over the closest part of the hypotenuse. So the hypotenuse, how long is the hypotenuse? That's 6, right? Hypotenuse 6 over x equals x over 4 is what it looks like to me. Cross multiply this guy, I get an x squared equals 24, square root. So x is exactly equal to, what's that going to be, 4 times 6 under the square roots? So 2 square roots of 6. If I were going to a rounded answer, that's going to be something like, I don't even know what that's going to be, 4.9 something. So now if I want to go to the y, I'm going to do the same setup, but I don't use this anymore. So I'm going to do hypotenuse over the leg equals the leg over the closest part of the hypotenuse. So the whole hypotenuse is still 6 over the leg is y equals y over 2. So y squared equals 12. Square root those. So y is going to be exactly equal to, what would that be? 4 times 3. 4 is a perfect square. So 2 square roots of 3. If I went to a rounded answer, that would probably be 3 point something, 5 or something like that. All right, so that's geometric mean. It takes some practice to get the hang of the formula. If you want to draw them out, all three, and set up from there, feel free to do so. Either way will work. Geometric mean formulas, proportions are just a shortcut for that. That is it for section 8.1. Thanks for hanging in there, and I will see you next time.